Okay, hello Cloud Gurus. Well, congratulations. You are at the end of the VPC section of the course. This is by far the hardest section, so congratulations, you've made it. Hopefully you've learned a lot. I seriously would not contemplate going and doing the exam if you do not know how to build out a VPC from memory, so please do go ahead and do it yourself and try and do it without watching my videos. Once you can do it from memory, you're pretty much ready to take the exam. You're going to nail all the networking questions. So what did we learn? Well, what did we start out by building? We built out this. So we built out a private VPC. We built out a custom VPC with a public and private subnet. We had our instances in our private subnet that could get internet access via the NAT gateway. We had a bunch of different route tables. Remember our default route table, we didn't want to have a public route out to our internet gateway. The reason for that is when we provision new subnets by default, they're always going to be associated with our default route table. Instead, what we want to do is create a new route table and basically put a route out using the internet gateway, and then basically we go in and every subnet that we want to make public we would associate with that route table. Moving on to NAT instances, so when creating a NAT instance, remember to disable your source and destination check on the instance. NAT instances must always be in a public subnet. There must always be a route out of the private subnet to the NAT instance in order for this to work, and the amount of traffic that NAT instance supports depends on the instance size. If you're bottlenecking, you just need to increase the instance size, and you can create highly available NAT instances using auto-scaling groups, multiple subnets in multiple availability zones, and a script to automate failure. To be honest, it's a pain. Why would you do that when you could use NAT gateways? And NAT instances are always behind a security group, whereas NAT gateways are preferred by the enterprise. They scale up automatically to 10 gigabits per second. There's no need to patch or do antivirus. They're not associated with security groups. They all are automatically assigned a public IP address. Remember to update your route tables when you provision a NAT gateway. Don't forget it can take about 10 or 15 minutes, and you get that little thing saying update your route tables immediately when you provision it. You still have to wait a while before you can actually go in and update your route tables, and there's no need to disable source destination checks on NAT gateways. And it's more secure than a NAT instance because you don't have to go in and patch it. Amazon take care of it all for you. Moving on to network access control lists. So your VPC automatically comes with a default network access control list, and by default it always allows all outbound and inbound traffic. You can then go and create your own custom network access control list. By default, each custom network access control list denies all outbound and inbound traffic until you go in and add your own rules. Each subnet in your VPC must be associated with a network access control list. If you don't explicitly associate a subnet with a network access control list, the subnet is automatically associated with the default network access control list, and you can associate a network access control list with multiple subnets. However, in vice versa, you can't have a subnet that's associated with multiple network access control lists. It can only be associated with one. When you associate a network access control list with a subnet, the previous association will be removed. Network access control lists contain a numbered list of rules, and they're evaluated in order, starting with the lowest number rule first. So if you do get a question on your exam, a scenario-based question, you've got a bunch of different NACLs and you have to say, how the traffic is going to work, start with the lowest rule first and then work your way up. Network access control lists have separate inbound and outbound rules, and each rule can either allow or deny traffic, and for this reason they're stateless, so responses to inbound traffic are then subject to the rules for outbound traffic and vice versa. It's not like security groups where you can just go in and open port 80 and it suddenly works. You have to do it on both sides, and you can also block IP addresses using your network access control list. You can't block IP addresses using security groups. Application load balancers, we basically just learnt that you would need at least 2 public subnets in order to deploy an application load balancer. We then went on to learn about VPC flow logs. Basically these are logs that enable monitoring of all network traffic across our Elastic network interfaces. You cannot enable flow logs for VPCs that appeared with your VPC unless the peering is done in the same account. You can't tag a flow log, and after you've created a flow log, you can't go in and change its configuration. So for example, you can't associate it with a different IAM role with the flow log. Remember that not all IP traffic is monitored, so traffic generated by instances when they contact the Amazon DNS server is not monitored. monitored. Traffic generated by Windows instances when they go in for license activations, not monitored. Traffic to and from your instance metadata calls is not monitored. DHCP traffic and traffic to the reserved IP address for the default VCP router is also not monitored. We then went on to VPC endpoints. So originally we had this setup where our instance in our private security, in our private subnet wanted to communicate to S3. It could do that via the NAT gateway, but it was sending information out across the internet. We then created a S3 endpoint. It was actually a gateway inside our private subnet. Remember that these endpoints can either be gateways or interfaces. Gateways are much more resilient and durable because they're not relying on just a single ENI, but an interface relies on a single ENI. And we then sent some, I've forgotten what we sent. I think it was some keys or something along to S3, from that instance. So that is it for the VPC section of the course. I hope you have learned a lot and had lots of fun. Remember to build out a VPC from memory before you go and do your exams, and feel free to move on to the next section. Thank you.